Let's go to Leak 1697, checking existence of age length limit path. For this question, it will give us integer n denotes there are n nodes in an age list. For this is a two-dimensional array. For each array has three elements, that is node ui and vi, and also the distance between ui and vi. And it gives us an two-dimensional array queries. And for each query, it gives us a start node, end node, and also a limit. So it is asked for this kind of start node and end node, for example, 0 and 1. Under this limit, whether there is any root can go through this 0 to 1. So this is 2, right? So 2, you see that the root should strictly less than limit, because there is a root equals 2. So this is false. And 0, 2 to be 5. We can see that 0, 2 here, right? So we find there is a root. This is going like this way, right? There is this path, the distance is 2. This path, the distance is 4. And both are on the 5. So this return true. So for this question, it didn't ask us to give the queries in like a string, right? So we can do it like in place, not in place, in like a stack bounded, right? Bounded. We can consider this as bounded data. So what we think about is that we can, as we are not saying the query, we should return the result by the query order. So we can think about, we can calculate the query with small limit first, and then calculate the query with bigger limit. So that we can what we think about is that on the small limit, right? We find all of the paths, for example, this under this limit. For example, this is limit 3, right? Then we will say for this kind of path and this kind of path, they exist. So we'll say under limit 3, we'll say 0, 1, and 2. There exist a path. So what we think about is that whether we check whether 0 and 2, there is a path between them. We can use some kind of union find or disjoint set to see whether 0 and 2 are connected. And as the question didn't ask to return the queries in order, what we're thinking about is that we going through the smallest query to the largest query. For example, there is 3, right? Then we can connect, have these two paths. Then I can union 0, 1, 1, and 2. And if there is, for example, the next limit is 5, we didn't find any path to exist. And then the next path possibly is 9, right? Then we'll say 8 exists again, right? In this case, we can also do a union between 0 and 2, right? So for so what we do is that we sort the queries by its limit, and also we need to sort the age list by its distance, right? As we sorted this kind of queries, right, and our result need to return with order. So for the queries, we need to have index with it. And what we do is that under this query limit, we trying to go through the age list, trying to find how many what kind of age exist. For example, for query one, right? And we find there are 3 age have the distance smaller than query one. Then we use union find to connect for these three paths, the start and end, right? And also for our query during we also for the query, right, when we connect how many edges are connected, and we check whether the query start end and end they are connected or not, right? So doing like this question, we thinking about is that the 2 pointers. One is for the age list, sort the age list. Another is the query list, right? And also use a union find. So let's begin to write code for this. We write a union find class. We have a father array, and also have constructor passing the int n, right? So we'll say father equals new int n, and we need to initialize int I equals 0 I smaller than n I plus plus. We should have each node the father equals to itself, and then we need to write union. So what we do is that if find a, let's write this int fa dot a equals find a, right? And the int fa dot b equals find b. We'll say if father fa dot a, let's say do this fa dot a doesn't equal to fa dot b. Then let fa is father pointing to fa dot b. Father a equals a dot b, right? Public int find int x. So what we do is that the int f if x equals father x, right? We just return x. And we'll say father x equals find father x, and in the end we'll just return father x, right? For this question, because we need to check whether 2 nodes they are connecting or not. So we can also write another help function called boolean, right? Is connected int a int b, just return find a equals find b, right? So this will be our union find function, and then let's have int q equals queries length. So what we need is return boolean, right? Boolean result equals new boolean q. And because we want to sort the queries, so we need to have an array, have the index with it, right? So we can do this. We create a new array called query array int Q, and we'll have another index that is query for, right? For int I equals 0, I smaller than Q, I plus plus Q array I 0 equals arrays I 0, right? And for the first three, we just put the same value. And for the last one, right? For the index 3, we put the index, right? So we are sort the queries by its limit, and also we need to sort the edge list by its distance, right? So we'll have to sort arrays sort edge list. So we'll have a lambda a b in integer compare a to b2, right? So we also need to sort query array. Let's use query array, Q array. So now create a unified instance equals new unified. And so what do we do is that for let's have a J index. J index is looping the edge list, and I index is iterate the query Q array list. So we'll have int j equals 0. Let's have m equals edge list dot length. So what we do is that for int I equals 0, I smaller than q, I plus plus, and was it while j smaller than m, and we should have the distance strictly less than the limit, right? H this j 2 smaller than q array I 2, right? Then in this case, we should have j keep it moving. While we're moving, we need to union connect the edge, the start and the end node, right? So you have union. And then this. So our result, right? Um, result, we need to make sure because this queries, sorry, its order has been it's not the original one, right? The QR is not already changed. So we are iterate the QR. So so we need to have this one as the result index, right? Should be equals UF. Then check if it is connected or not, right? Connected. This query array 0 and query these two these two nodes, start node and end node, right? Then we return result. So this will be the Java code for this. should be 1, 2. Okay, doing like this, that's the analysis of time complexity. There is a sort for queries, right? So that is Q log Q, and then of course this is N log N, right? And for this kind of while loop, that is 2 pointers. That is the max Q and N, right? So this is linear. Then the union find every operation is O1, right? So actually the time complexity will be a Q log Q and N log N the maximum, right? So this is Java code. Let's write a Python code quickly. We also need the the union find class, right? So because let's write the class, okay, class union find. So we need the constructor. In Python, the constructor is used to underscore I underscore. And we need to have a self, right? Self here. And because if we want to initialize this class, so we need to have a self here. And we'll have a self of father equals list range. And then we write the find method, the find, right? Find self x, because we want to use this outside. So we need to have a self here. If x doesn't equal to self dot find x, self father x, we just return x. And we'll say if this one equals, right, equals to this, then return x. Then we'll say self dot father x equals find self dot father x, right? And then return self dot father x. So this is find, and also needed to define the union. Union, we should have self A and B. So what we do is fa dot A equals find A, fa dot B equals find B. And we'll say if fa dot A doesn't equal to fa dot B, then we'll connect these two, right? Self father fa dot A equals fa dot B, right? And also we need to define another one, which is check the connections. Def is connected self A, B. We just need to make sure, find out whether the parents are equal, right? Return self dot find A, find A equals self find B. right? So in this case, we write the union find class, and also we implement the constructor, the find method, the union method, and the isConnect method. Then we do the same thing here, right? We'll have Q equals length queries. We need to create another array called the Q array, right? Q array equals still get the size, right? For in range Q. Then for I in range Q, right? What we do is the Q array I 0 equals queries I 0, and also 1, 2, 3, right? 1, 2, 3, 1, 2, and the last one is the index, right? We need to sort both the edge list and the queries on the second element. So let's write. How can we write this one? We'll write edge list sort key. Sort the sort key equals, right? So we write lam x to because we are sort based on the second the distance and the edges, right? And also we need to have the Q array dot p equals x to so after sort we need to have the result, right? So we know result equals false multiplied by Q, right? Then we use for two for loops, and j equals something, m equals something, j equals 0, m equals this length, h this. Then we use for I in range Q. We need to have while loop, right? While j is smaller than m, and h list j2 smaller than the limit, right? Q array I2. Then we'll have j plus plus. Of course, we need to union all of the roots which have the distance smaller than this the limit, right? We have union which list I0 and h list I1, right? And it should be j plus equal 1, right? Plus equal to 1. Comparison is j plus equal to 1. And we all have the for this I, right? We're trying to check whether they are connected. So I have a result Q array I3 equals UF is connected. Q array I 0 and Q array I 1 I. And then in the end, we just return result. We didn't initialize the union find, right? So we need to have the union find, put the union find here, right? UF equals union find A, right? It's no arguments. Um, union find. UF equals union find A. Union find takes no arguments. Union find. And this construct have a right. Um, union find. What's the problem? So, and insurance. Um, is correct, right? Def. Do I have def? Mm, Then query, right? So should be query. And it's not mm, should be self, right? Self dot find a. And also this is self dot find b. This is the self dot find. false, false, true, false. Looks like we are not connected, right? Info self file. So if in this case we needed to union J plus equal to 1. Looks like they are not a union, right? Okay, yeah, fine. We need to have a str, right? Mm. So looks like we never been union. This kind of path will never be union. This index is wrong, right? We need to index union J, not in union I. J0 and J1, right? Okay, this is the Python code.